Hello. Now we will calculate the electric field in general location. So this is my dipole minus q plus q, and the dipole moment is p, and we want to calculate the electric field due to this system at point P. So this point P is at a distance x with respect to point O, which is the midpoint of this dipole, and the position vector of point P is given x. Now this position vector of P with respect to O is making an angle theta with respect to this P dipole moment. So the first thing we did here, we took component of this dipole moment, one along this line joining OP and one perpendicular to it. So the component of P along the line joining OP is P cos theta, because this angle is theta. And the component of P along perpendicular to OP is P sin theta. Okay, so this OP, let's say this is the axis basically, OP is the axis. So at point P, when we want to calculate electric field at point P, the electric field at point P we divide into two categories. One along line OP and the one perpendicular to OP, ET I'm calling. So one is ER, which is along line OP, and one is ET, which is perpendicular to line OP. So for this ER, if we want to calculate ER, for this ER, this P cos theta will be the component along OP of P. So if this P cos theta is the component along OP, then this line OP, this ER is the electric field along the axis. This electric field ER is the electric field along the axis. So if we remember the case 1, so when we calculate the electric field along the dipole moment, that was P. In this case, it is P cos theta. The formula is electric field is 1 upon 4 pi epsilon naught 2p upon x cube. That was the formula. But in this case, we'll not take P, because P is not the component along OP. The component along OP is P cos theta. So this ER from the same logic will become 1 upon 4 pi epsilon naught 2p cos theta upon x cube. Because the electric field along the axis, this is the new axis, this is the point P, this is the new axis. So this electric field along the axis we calculate from that formula 2p upon x cube. Okay, now let's talk about ET. ET is perpendicular to axis. So case 2, when we were calculating the electric field along perpendicular bisector, the electric field was perpendicular to the perpendicular bisector. So it was perpendicular to the position vector. So electric field which was perpendicular to this position vector, we had the formula for that also. So that formula was P upon x cube, 1 upon 4 pi epsilon naught P upon x cube. So see, we have two formulas, we have in two cases. In one case, when the electric field came along the position vector, we had formula for that. That was 1 upon 4 pi epsilon naught, that was a constant, 2p upon x cube. And the second case was when the electric field was perpendicular to position vector. That was the case when we were calculating it along perpendicular bisector. Then the formula was 1 upon 4 pi epsilon naught P upon x cube. So in the first case, this P was along the line. And along the line, we have P cos theta. It's not P. So what we did in this formula, we replaced P by P cos theta. Now we want to calculate this electric field ET. So in this formula, if you remember, this P was perpendicular to the perpendicular bisector. The electric field was perpendicular to the perpendicular bisector, because you see, this position vector was along perpendicular bisector, electric field was perpendicular to perpendicular bisector, and the P was opposite to that. So opposite to that, we have to take the component of P, which is not P cos theta, it is P sin theta. So in place of P, we'll replace by P sin theta. So it will become 1 upon 4 pi epsilon naught P sin theta upon x cube. So these two becomes the component of electric field at point P, but we don't need the component, we need the actual field. So the electric field at point P will become under root of ER square plus ET square. If you take the square and if you add those values, by simplifying it, you will be getting 1 upon 4 pi epsilon naught, you will be taking it out. P upon x cube also you will be taking it out. And inside you will be having sin square theta plus 4 times of cos square theta. And if you can further simplify it, the value will come out to be 1 upon 4 pi epsilon naught P upon x cube under root of 1 plus 3 cos squared theta. So this becomes the net electric field at general point. Okay, but we should not memorize this formula if we can memorize these one. My suggestion will be you should memorize these two formulas. One is the field which is along the position vector, and second is the field which is perpendicular to the position vector. And these two formulas we can convert into vector format also if you want. This is along the rx r cap, and this is along the t cap, tangential. So you make the position vector, one component you show along the position vector, and second you show perpendicular to this vector. Now since we are calculating the net field, this is the net electric field here, EP. So we should define the angle of this net electric field with the position vector. So existing position vector is OP. So if I want to define the angle, so let's calculate the tan of that angle. I'm defining the beta. The beta is the angle net electric field at point P is making with the position vector. So tan beta will be, if you can see, this is the net electric field. This by this will be the net electric field. So angle, tan of angle. So E tangential upon E radial. So if you take the division of these two, 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught, they are going to cancel. P and x cube, they are also going to cancel each other. So we'll be having sine theta upon 2 cos theta. That will be 1 upon tan theta. That is tan beta. So beta will be equals to tan inverse tan theta by 2. That is the angle net electric field will be making with the existing position vector. So if you define that, if you want to calculate the general electric field at general locations, first you have to draw the position vector. Then you have to define the angle of that position vector with respect to the existing dipole. Once you define that angle, you should divide the electric field at that point into two components. One along the radius vector or position vector, and second perpendicular to it. And these two formulas one should memorize. Once you have these two formulas, and if you can memorize these two formulas, these values you can directly derive from these two formulas. And this is the angle net electric field will be making with existing position vector. This is the derivation. Okay. Thank you.